Hello students, let's move on to the next question of miscellaneous exercise. This is question number 25 and from here the point of definite integral starts. Yes, in miscellaneous also they have divided the first 24 questions were based on indefinite. The next few are based on definite integration as we'll see over here. So 25th question says you have to integrate from pi by 2 to pi this e power x times 1 minus sin x upon 1 minus cos x. And the moment you see this e power x, the thought which comes to mind is, oh, why not convert it into a special integral and integrate, right? So e power x times trigonometric function, this can be written as fx plus f prime x, okay? Integral of e power x fx plus f prime x, if you can do that, then that integral will be nothing but e power x times fx, right? That's the important key. And once you are able to convert this particular bracket, the function in the bracket, as fx plus f prime x form, you can easily integrate. Then substituting the limits will not be an issue. Now how will we convert this? So what do I have? I have 1 minus cos x, right? And in the numerator I have 1 minus sin x, right? So in the numerator I can split, but this denominator is a bit complicated. This 1 upon 1 minus cos x, if that becomes fx, then f prime x will be derivative of this, right? Which will have 1 minus cos x square in the denominator. So we'll not deal with this cos x and sin x, 1 minus cos x as it is. We'll try to convert this, simplify this first. And if you recall, we saw such kind of question in the, let us say in the questions related to indefinite also. 1 minus cos x can be converted into half angles maybe, yes. So this particular will convert into one single term. 1 minus cos x will be written as 2 sin square x by 2. Can I do that? Yes. So 1 minus cos x, if it is written as 2 sin square x by 2, this sin x can also be written as half angle x by 2 in terms of that. Yes, yes. And now after that, if I split, what do I get? Let's see, let's see. So this is 25th. I is equal to integral from pi by 2 to pi. E power x is okay. Yes. 1 minus sin x is okay. Over 1 minus cos x, I am writing 1 minus cos x as 2 sin square x by 2 because this is equal to this also. Yes. I can also write the sin x. I can also simplify this sin x. Yes, yes, I can also simplify that. Let's simplify that as well. Sin x will be equal to what? Sin x will be simplified into 2 sin x by 2 cos x by 2. Yes. This is what you will get. Okay, dx. Once I write it as this, then the next thing becomes very clear over here. Pi by 2 to pi, e power x is okay. What is this? 1 by 2 sin square x by 2, which is nothing but 1 by 2 cosec square x by 2. There's a minus, then what do you have? 2 and 2 get cancelled. Sin x by 2, sin x by 2 will get cancelled. There will be 1 sin x by 2 remaining. In the numerator, you'll have cos x by 2. In the denominator, sin x by 2. That will be written as cot x by 2 dx. This is what you'll have. Okay, half cosec square x by 2 minus cot x by 2 times e power x from pi by 2 to pi. This is what you have. Is that okay? Yes. That looks pretty much okay. What else? If you observe carefully, if this minus cot x by 2 is taken as fx, then its derivative, which is minus of minus cosec square x by 2 with 1 by 2, because derivative of x by 2 is 1 by 2. If this whole minus cot x by 2 is taken as f, then this here is nothing but f prime. This is important to observe, and if you observe this carefully, then you can directly write I as integral will be e power x times minus cot x by 2, that is fx, from pi by 2 to pi. Okay, and what does this simplify into? Now we can put the limits over here. This will be e power pi times minus cot pi by 2. Now cot pi by 2 will be 0. So this is 0 minus e power pi by 2 times minus of cot pi by 4, which is 1. Yes, x by 2 will be pi by 4. So this will become minus 1, which is e power pi by 2. And that is my required answer for this particular question, number 25, as you can see over here. Yes.